Yep. Thank you. Hi, my name is Hugo. I run my own little company called Little Robots. I'm also a GDE, Google Developer Expert for Android. And I am one of the leads of the Dutch Android user group in the Netherlands. So this is how you can reach me. And this little thing here, it's called the LightBlue Bean. It's a tiny IoT prototyping module, and it pairs an Arduino with a Bluetooth low energy module. And it has a temperature sensor on it, it has an accelerometer on it, and not sure if it's visible, but it has a LED also. And so this thing runs code. There's actually now a program running on this thing, making the lights flash. So that's how I get started with Bluetooth Low Energy. So this is just to give you some context. For this thing, there was no Android SDK. So I set out to build one myself based on the iOS SDK that was available. So last year, around July, I released this thing. It's MIT licensed, so you can do whatever you want with it. It's open source. And there's an example of what you can do with it. So I'm scanning for some beans. And then you can see, show some battery level information, some other stuff. And once you start shaking this thing, then it will plot out the accelerometer graphs. So I only got 20 minutes, so there's a lot to cover. So I'll just dive right into what Android and Bluetooth Low Energy has to offer. So it has been in the platform since KitKat. In KitKat, they totally rewrote the whole Bluetooth stack. It's called BlueDroid. And then at KitKat, they also introduced the Bluetooth Low Energy stuff. So it's important to understand that there are basically two flavors of Bluetooth. There's the classical Bluetooth, which you use when you connect your phone to a car kit or to a wireless headset. And that's optimized for really streaming large amounts of data, relatively large. And there's like the low energy stuff, which is obviously for low energy applications. So this bean, for example, depending on what you do with it, it can run up on a single coin cell battery. It runs a couple of weeks, a couple of months, depending on the programs you run on it. So these Bluetooth low energy use cases are usually for devices that require a little data overhead for heart rate monitors, wearables, that kind of stuff. So to get started on Android, first you have to declare some permissions, of course. Well, maybe not when M is introduced, but for now you still do. You need two permissions. You actually need the Bluetooth permission and you need the Bluetooth admin permission. The Bluetooth permission is to make a connection to a device. Admin is for scanning. In practice, you need both. If you have an app that really requires Bluetooth, then you should also specify that in the manifest so that it doesn't install on devices that don't support Bluetooth Low Energy. Usually, though, if you have an app that, for example, works with beacons but doesn't really require a beacon, then you can also do this check at runtime by just using the package manager for that. So the first step would be scanning and finding a Bluetooth Low Energy device. So these devices are basically broadcasting their presence all the time, typically around once a second. This is quite different from classical Bluetooth already, because in Bluetooth you have to put your device in visible mode and then you can only connect to it. So not in this case, it's just broadcasting all the time. So first you have to get a Bluetooth adapter to actually start scanning. So how do you do that? You get them from the system service that is introduced in KitKat as well. There's also an older API that still works, but the first one is preferred. Then you, of course, have to check if Bluetooth is enabled, and there's a method for that on the adapter. If it isn't, then you can fire off an intent to ask the user to enable it. There's also an API to enable it, but that's just very rude. You should never use that, basically. I'm not sure why it is in the API, but don't do that. Then we're off to finding a device. So this thing is broadcasting all of the time. And here you can already see there's a different API for scanning. If you're familiar with Bluetooth, there's a different API for low energy, so it's called Start LE Scan. It takes a LE Scan callback, and in that callback you will get the device the signal strength, and the raw advertising packet that, that the device is broadcasting, so the raw bytes on protocol level. And as you might notice, this thing returns a Boolean. So the first question is, what the does false mean? I want to scan, and it returns false. So most likely, Bluetooth is turned off. But you usually check for that. So, so then what's the other option? The other option is, unfortunately, especially on KitKat, Jelly Bean, there are some infamous bugs where after a certain amount of scan, the whole Bluetooth stack would just stop scanning. You could work around that by toggling Wi-Fi or toggling Bluetooth even, or maybe do a classical Bluetooth scan. But it's quite annoying that it just stops working. You have some fake errors in the log. Yeah, so that's one of the bumps that I ran into when building this SDK. And the other question is, how many callbacks will you get for each device that you find? So you might have guessed it. It depends. It depends on the type of device that you're using it on. On some devices, you will get one callback for any Bluetooth device at any time. On other devices, you will get each time the device is broadcasting, you will get a callback. And that's quite annoying, especially if you're working with beacons. Then you really want to know, we want to catch every broadcast, because you might be moving along the beacon, and you want to know if you are closing by or if you're, if you're near or close to the beacon. If you're dealing with a heart rate monitor, it's probably okay to just catch one broadcast of that thing, because chances are pretty slim that the heart rate monitor is going anywhere. But yeah, it's quite annoying that it's not consistent. And then there's this other thing. Usually you don't want to find any Bluetooth device. You want to find a particular device of what your app is supporting. For example, if you're dealing with a heart rate monitor, you want to scan for heart rate monitors. It doesn't make any sense to connect to these kinds of things. So there is a variant for the start release scan that takes a service UEID. And so every Bluetooth device has services. And these services are identified by a unique ID. And these unique ID come basically in two flavors. So you have the Bluetooth assigned ones. So the Bluetooth committee has decided that this is the specified UEID for a heart rate monitor. And you have UEIDs that a vendor can make up. And that's totally fine. A vendor can just invent his own UEID. Now, this method does not work with vendor-specified UEIDs. So when I was trying the SDK for the Bean, it didn't find this device, even if I passed in the UEID. And there are some nasty workarounds that you can do. It basically boils down that you have to parse the byte arrays coming from the advertisement as well. So that's quite annoying as well. So now for some good news. All of this stuff is deprecated in Lollipop. Depending on how you look at it, it's good news. In Lollipop, they introduced a more capable Bluetooth scanner, and that supports filtering of devices, it supports batching of results. It also supports low power modes, so it's more feasible to be scanning all the time in the background. It wasn't on KitKat or Jelly Bean, because that still uses a lot of power on your cell phone. And well, it's actually pretty easy. You set the UEID. In this case, it's the UEID for the serial service of the thing. You get the adapter. You build a scan filter, and scan filter can take like a service UEID, but can also take other options. It's very powerful. And you get some scan settings. Then you get the Bluetooth LE scanner, and you call start scan on it. And it takes, like I said, it takes the scan filters, takes the settings, and a scan callback. And what's already nice here that there's no longer Booleans, it's just a callback when something bad happened with a proper error code. So that's nice. What's also nice is that you no longer have to deal with byte arrays, parsing yourself. You now get a properly parsed scan result object. So that's already an improvement. Yeah, there's one more thing though. Not all of these features are supported on every device. The filtering and the low power modes require hardware support. And there are two Boolean methods to tell you if it's supported. For example, Nexus 5 does not support low power modes. And if you try to use them on a device that does not support it, you will immediately get an error callback. So yeah, that's scanning. If you're not dealing with a beacon or something that you don't want to connect to, then you probably are going for this step, actually connecting to the device. It's pretty easy. There's a connect-get method on the Bluetooth device. It takes a context, because, hey, everything in Android takes a context. There's an auto-connect flag, and there's a Bluetooth get callback. And the callback is basically your callback for everything related to the device once it's connected. It returns a Bluetooth get object, and it's really important to manage that object because that represents the connection to your device. If you lose a reference to that object, then in most cases it will stay connected for a while. And if the device is connected, you cannot scan for it, and you cannot connect to it again. There's no way to disconnect it as well. So that's quite inconvenient. So you should really manage that like crazy, especially if you're dealing with activities, of course. If you rotate your activity goes away, reference might be gone. Nasty things happen. So don't forget to close this object when you're done with the device. Or maybe stuff it in some kind of singleton of service or whatever. Then there's this question of the auto-connect flag. That's really an odd thing. I recommend against using it. It's not really clear what it should do, how it should work, how fast it will reconnect, will it try once, whatever. The behavior is totally unclear, and most apps should really not rely on this and manage the connection on your own. And that's typically what most Bluetooth apps do. So, the Bluetooth get callback. That has a typical sequence. You usually will go to on-connection state change, which will tell you if you're actually connected. Once you're connected, you can't really do anything with the device yet. You first have to discover its services to find out what device you are dealing with. That will yield in a callback on services discovered. And there you can figure out what kind of device it is, what kind of properties it has, and then you're ready to go and read, write these properties, or subscribe to it. And of course, when you're done with all of this, you close the connection again. So this is how that would look. You just call connect get. Then you get the on-connection state change. Well, you check if the status is successful. And I really recommend to check for success, because I've always seen there's also some options that you get. Statuses here that are not defined in the API anywhere, so just assume if it's success, we're fine. If it's something else, it's a failure. So you check if you're connected, and then you try to discover the services. Unfortunately, that also returns a Boolean. So if it returns a Boolean, you basically have no clue why it failed, so just close the connection. If it did work, then at some point we will get on services discovered. And there you just retrieve the service based on the unique UUID again. So if you would be dealing with a heart rate monitor, then you know what its UUID is, and you will get that from the service. If it's not supported, then it would return null here. And well, in that case, probably something bad happened. You're connected to a device which has not the service that you are expecting, so you close the connection again. What's not in the documentation, that there's a maximum amount of connections that your device can have to a Bluetooth devices in general at any time. And on KitKat, it's 4 connections in total. And on Jelly Bean and up, it's 7. So if you have connected a wearable to your device, then you're already 1 connection down. And this is only be found in the source code of BlueDroid. So go figure. So characteristics. Characteristics are the properties that you want to read from the device. So in the case of a heart rate monitor, it would be the actual heart rate reading. In case of this device, it's more communicating with the protocol. So how do you read these characteristics? In the on-services discovered, you get a reference to the characteristic based on its UUID, which you will get from the services. So on this slide, it's not shown how you get the service, but yeah, it's a slide, so it's not real code. Then you try to read the characteristic, and again, that might fail. So if it fails, then you close the connection. If it did work, then you get an on-characteristic read callback. And again, it returns a status, so you should check if it's successful. If it's successful, yay, we got some data. You just get it from the characteristic. And there are some options there. You can get it as a byte array or as a string or other variants. And one thing that also might happen is that you get the get insufficient authentication status, which basically means that you need to pair the device. And compared to classical Bluetooth, that's pretty late in the game. Usually on classical Bluetooth, you can't even connect if it's not paired. But here you can just connect and discover services and do whatever what you want with the device until you read something, and then we'll say, well, you need to pair. On KitKat, there's no API for pairing the device programmatically, but there is on starting on Jelly Bean. And in any case, you probably want to close the connection, do the pairing dance, and then connect again. So what makes Bluetooth low energy actually low energy is that the device can tell you when something changed. So that's called notifications. And this is how you set them up. On service discovered, you still get the service and the characteristic. And then you will call the get set characteristic notification with the characteristic and a Boolean. And you would sort of expect that this would be done, then everything is fine, but that's not the case. There's also a thing called a descriptor on Bluetooth. So a characteristic has descriptors, which are metadata that you can read and write on the characteristic. For example, it gives you some information on what this characteristic is about, and it also can specify if this characteristic is able to notify you when it changed. So here's the UEID for the notification descriptor, and it's a set UEID specified by the Bluetooth committee. So if you find this UEID, then you know it's able to notify you. So then you need to write to this descriptor. You'll set enable notification value. It's just a constant. You try to write it again, might fail again. So if it fails, then close it. And if it worked and the status is success, profit. We now get notifications. Awesome. So every time now that characteristic changes, you get a callback. You just get the value from that callback. Oh, skipping a slide. So there are, again, some undocumented limits here, only to be found in the source code. There's a maximum amount of notifications that you can have per connection. It's 4 on KitKat, it's 7 on Jelly Bean, and 15 on Lollipop and Up, which is quite annoying. I mean, this thing already has 7 or 8 interesting properties, characteristics that you want to be notified of. So 4 is definitely not enough. 7 is better, and 15 is probably all right for most cases. And then again, you won't find these limits until you find some vague error in the logcat, and then you start digging in the source code of Android. So this really should be documented. Okay, we did some reading, we did some subscription. Writing is it's not that hard. You just set the value on the characteristic, which you have a reference for, and then you call write characteristic with, again, can return false. If it returns false, no clue why, just close. It's very important that you wait for the on-characteristic write callback, because if you start writing here in a loop, for example, then you will just drop packets and you will not send anything to the device. That means that in the SDK, I'm really juggling writes in that sense, because by definition, this thing, I'm sending commands to that thing. And a command can be larger than 20 bytes, and 20 bytes is like the maximum size that you can put in a characteristic. So that means assembling packets, making sure that everything is written correctly, then writing the next is kind of a hassle. And this thing makes it even harder because it uses a single characteristic for both reading and writing. Okay, so that leads up to some conclusions. Well, Android has full support of Bluetooth Low Energy starting in KitKat. It's been maturing, especially in Lollipop. The Bluetooth Low Energy related APIs, they are really low level. It's like they just wrapped the C code and gave you a Java interface. There's error checking all over the place, and it's really hard to get right. I'm pretty sure I didn't got it correctly right in the Bean SDK. And the documentation could use some work. It's unclear how some behaviors work. There's just the limits are missing. So some other observations. There's a lot of complexity in managing multiple characteristics in a single callback. So if you have a non-trivial device, then you end up with a huge callback that needs to handle all the cases. And what I said, the low-level interface, it seems pretty straightforward, but it's difficult to get it totally right. If you want to learn more about this stuff, well, you can, of course, take a look at the SDK, even if you're not dealing with the Bean, just for some Bluetooth code. There's a good starter on developer.android.com. And if you want to learn more about the Bean, then just visit their site. And that's all I have. Thank you.